previous videos, we've gone over how to determine where two lines intersect by graphing or solving a systems of equations by graphing. You don't always have a graph, so we need other methods to figure out where these two lines intersect other than graphing. And one of these methods is substitution. When you use substitution, what I'm going to do is I'm going to make sure that each one of these equations is in slope-intercept form. And we've gone over what slope-intercept form is. It has to start off with y is equal to, then there needs to be a number in front of the x, which is the slope, and the y-intercept here on the end. If both of these are in slope-intercept form, I'm basically going to use substitution and algebra to figure out where these two lines intersect. I'm going to figure out the point where these two lines intersect. Now remember, a point consists of an x-coordinate and a y-coordinate. And when these equations are in slope-intercept form, you can use this technique right here. If they're in slope-intercept form, it's telling me that y is equal to this right here, negative 3x plus 7, and it's telling me that y is equal to 2x minus 18. If y is equal to this expression and this expression, that means I can take these two expressions that have the x's in them and I can set them equal to each other. If y is equal to negative 3x plus 7 and y is equal to 2x minus 18, then those two things are equal to each other. And what I'm going to do is I'm going to solve this equation, and then once I solve this equation, I'll have my x-coordinate. I'll have half my answer here. So what I need to do is go over my rules for solving equations. To solve this equation right here, I look and see which variable is in the wrong spot. That would be my 2x. The opposite of 2x is negative 2x. I subtract 2x from both sides to eliminate this x over here on the wrong side. Negative 3x minus 2x, negative 5x. Bring down the plus 7 is equal to, bring down negative 18, and I continue to solve this. I need to get rid of this positive 7 because I need to add or subtract before I undo my multiplication and division. The opposite of positive 7, negative 7. Subtract 7 from both sides. That will eliminate this positive 7 right here. Is equal to negative 18 minus 7, negative 25. The last number I need to get rid of is this negative 5. The opposite of multiplying by negative 5 is dividing by negative 5. Divide both sides by negative 5. A negative divided by a negative is a positive. I have determined what my x-coordinate is. I now need to determine the y-coordinate. And once I determine the y-coordinate, I'll have the point where these two lines right here intersect. I'm going to use substitution again, meaning what I basically did was substitute this and this in for y. I'm going to substitute this into one of those equations and figure out what the y is equal to. What I'm going to do is I'm always going to substitute it into that top equation up there. Y is equal to negative 3, and where the x is, I'm going to put a 5 plus 7. Follow my order of operations. That means I multiply these together, get negative 15 plus 7, and negative 15 plus 7 is negative 8. That is the y-coordinate. This is the point these two lines intersect. So here's a second example. I need to determine where these two lines intersect. I don't have any graph paper, so I'm going to use one of these other techniques. And the technique that we've gone over is substitution. If I'm going to use substitution, I want both my equations to be in slope-intercept form. That means it needs to be y is equal to. Y is equal to. Both of them are in slope-intercept form. Since they're both set in slope-intercept form, this expression is equal to this expression right down here. Y is equal to this and y is equal to this. That means these two things, these two expressions are equal to each other. That means 5x plus 6 is equal to 4x minus 12. I solve this and I'll figure out what my x-coordinate is. To solve this, I need to get rid of the variable in the wrong spot. That would be this 4x. Opposite of 4x is negative 4x. Subtract 4x from both sides and it's going to eliminate that x from that side. Negative 5x minus 4x, negative 9x. bring down plus 6, bring down my equal sign, bring down negative 12. Now I need to get rid of these two numbers. I need to get rid of my adding and subtracting before I get rid of my multiplication and division. The opposite of positive 6 is negative 6. Subtract 6 from both sides. Bring down my negative 9x. That was eliminated. Bring down my equal sign. Negative 12 and negative 6 put together, negative 18. Now I need to do the opposite of multiplying by negative 9. That's dividing by negative 9. Divide both sides by negative 9. That negative 9 is eliminated. X is equal to a negative divided by a negative is a positive. 18 divided by 9 is 2. I have determined what my x coordinate is. My x coordinate is 2. I need to find out what my y coordinate is. The way I'm going to do that is I'm going to take that x and I'm going to plug it into that top equation right there. Y is equal to negative 5, parentheses, 2, because I'm multiplying those together, plus 6. Negative 5 times 2 is negative 10, and negative 10 plus 6, my y coordinate is negative 4. My y coordinate is negative 4. This is the point these two lines intersect, and I was able to do that using algebra instead of having to use a piece of graph paper and graphing each one of those. So right now, for substitution, make sure these equations are in slope-intercept form. We're going to solve this system using substitution. Are these equations in slope-intercept form? Yes. Since they're in slope-intercept form, that means I can set this expression equal to this expression, because y is equal to this and y is equal to this. That means this expression is equal to this expression. Now what makes this one different than the other ones? There are fractions in this one. So to get rid of fractions in an equation, you need to multiply by a common denominator. What's the only number that's a denominator up here? 3. That means I'm going to multiply this entire equation, everything in the equation, by 3, and it will eliminate these fractions. 3 times 2 is 6, divided by 3, 2x, plus 3 times 3 is 9, is equal to 3 times negative 4, negative 12, divided by 3, negative 4, and make sure I put that x with it. 3 times negative 3 is negative 9. Now I simply need to solve this equation. Which variable is in the wrong spot? This one right here. Get rid of this by doing the opposite of negative 4x, positive 4x. That will eliminate that x from that side. 2x plus 4x equals 6x. Bring down plus 9 is equal to negative 9. I need to get rid of my adding and subtracting before my multiplying and dividing. Opposite of positive 9 is negative 9. Subtract 9 from both sides. That's eliminated. Negative 9 and negative 9 put together, negative 18. The opposite of multiplying by 6 is dividing by 6. X is equal to negative 3. Negative 18 divided by 6 is negative 3. This is my x coordinate for this problem. My x coordinate is negative 3. I now need to find the y coordinate. So what I'm going to do is I'm going to take this x and I'm going to plug it or substitute it into that spot right there. And here's me working that out. Y is equal to 2/3 times negative 3 plus 3. Y is equal to negative 3 times 2 is negative 6, divided by 3 is negative 2 plus 3. And negative 2 plus 3 is 1. That's my y coordinate for this problem. We're going to solve this system by using substitution. That means I'm not going to use a piece of graph paper. I'm going to use algebra to solve this. And to use substitution, it would be nice if these were in slope-intercept form. Is this one in slope-intercept form? Yes. Is this one? Yes. This is telling me y is equal to this and y is equal to this. That means these two things are equal to each other. That means 3/2 x minus 4 is equal to 1/4 x plus 1. I need to find a common denominator to get rid of these fractions in this problem. One way of finding a common denominator is simply to multiply my denominators together. And that's what I'm going to do. Now, a good common denominator is 4, but some people can't find a common denominator. The best common denominator, you can always multiply these two numbers together and you'll get a number that works every single time. So I'm going to multiply this entire equation by 8. 2 times 4 is 8. So 8 times 3 is 24, divided by 2 is 12x. 8 times negative 4, negative 32, is equal to 8 times 1 is 8, divided by 4 is 2x, and 8 times 1 is 8. So I got rid of these fractions by multiplying by a common denominator. I now need to solve this. Which variable is in the wrong spot? This one. I need to get rid of this by subtracting 2x from both sides. Subtract this, I get 10x, bring down negative 32 is equal to, that's eliminated, 8. Get rid of negative 32 first by adding 32 to both sides. 10x is equal to 8 plus 32 is 40. The opposite of multiplying by 10 is dividing by 10. X is equal to 4. I have determined my x coordinate to be 4. Now I need to find the y coordinate. The way I find my y coordinate is I take this x and I'm simply going to plug it in to that first equation right there. And when I do that, it looks like this. Y is equal to 3 halves times 4 minus 4. Take this 4 and multiply it to 3 halves. 4 times 3 is 12, divided by 2 is 6. Y is equal to 6 minus 4. And 6 minus 4 is 2. That's my y coordinate for this problem. This is the point these two lines intersect. And I did this by using substitution instead of graphing it on a piece of graph paper. For sometimes this type of problem, which is extremely easy, gives people problems because it doesn't look like the other ones. What makes this one really easy is half the work is already done for you. I'm trying to determine where these two lines intersect, and guess what? They've already given me one of the coordinates. This equation has nothing else in it. It's telling me the y will always be equal to negative 2. So in my answer, my y better be negative 2. I put a negative 2 right there. The only thing I have to do now is use substitution. Even though this is not in slope-intercept form, the only thing I have to do is take that 2 and plug it into this equation, and I'll figure out what my x is. So let's do that. I'll plug it in there. Negative 3x plus 10 times negative 2 equals negative 8. Multiply those together. 10 times negative 2, negative 20, is equal to negative 8. Add 20 to both sides. Negative 3x is equal to negative 8 plus 20 is 12. The opposite of multiplying by negative 3 is dividing by negative 3. X is equal to 12 divided by negative 3 is negative 4. That is my x coordinate. This is the point these two lines intersect. In this next example, we're going to go over a situation where one of the equations is not in slope-intercept form. This one up here in the top is not in slope-intercept form. So to do it like we were doing the other examples, what I need to do is change this into slope-intercept form. And we've gone over how to change something into slope-intercept form. So I'm going to do that over here to the side. I'm going to change this equation into slope-intercept form. Slope-intercept form starts off with y is equal to. So this x needs to be over here on the other side. I need to get rid of this 4x. The opposite of 4x is negative 4x. So I'm going to subtract 4x from both sides. This is eliminated. Negative y is equal to, I can't combine these together, but I need to put them in the correct order. That would be negative 4x and then minus 3. The next thing I need to do is make sure that this y is completely by itself. This has got negative y, so what I'm simply going to do is if I want this to be positive y, I'm going to change the sign of everything. If I change the sign of one of them, I change the sign of all of them. Y is equal to 4x plus 3. This equation right here and this equation right here are the exact same equation. I just changed the order. This one happened to be in standard form. I just changed it to slope-intercept form. So what I'm going to do is I'm going to write this one below it. And this is the one. These are the two equations I'm going to use. I'm not going to use this one anymore because it wasn't in the right order. These are the two I'm going to use, and now I'm going to do it just like all the previous examples. Since it says y is equal to, I'm going to set these two expressions equal to each other. That means negative x minus 2 is equal to 4x plus 3. Which variable is in the wrong spot? The 4x. I'm going to eliminate that by subtracting 4x from both sides. Remember, there is a 1 sitting in front of this. In fact, that's negative 1. That's negative 1x minus 4x, negative 5x. Bring down the negative 2 is equal to, that's eliminated, 3. I need to do my adding and subtracting before my multiplying and dividing. The opposite of negative 2 is positive 2. Add 2 to both sides. Negative 5x, that's eliminated, is equal to 5. The opposite of multiplying by negative 5 is dividing by negative 5. X is equal to 5 divided by negative 5, negative 1. Now, like the previous ones, I need to take this and plug it into one of these equations. It doesn't matter which one. I could even plug it into this one, but we're simply going to use these two right here. So I'm going to take it and I'm going to plug it into this one right here. When I do that, it looks like this. Y is equal to, look, that's negative x. The parentheses is where the x is, minus 2. And what number goes in for x? Negative 1. That's a negative times a negative. That should be positive 1 minus 2. Positive 1 minus 2, y is equal to negative 1 also. So now I can write the coordinates of the point where these two lines intersect. Negative 1, negative 1. That's the point these two lines right here intersect. The black lines and these two, because this one and this one are exactly the same. Remember, if these equations are not in slope-intercept form, I need to change them into slope-intercept form. Is the top one in slope-intercept form? No. So what I'm going to do is I'm going to rewrite it, and I'm going to change this one into slope-intercept form. Slope-intercept form starts off with y. That means I need to get rid of this 3x. Subtract 3x. Subtract 3x. Negative y is equal to, these can't be put together. They're not like terms. So I need to put them in the correct order. When something's in slope-intercept form, the y needs to be by itself. Right now it's got a negative there. What I'm going to do is I'm just simply going to change the sign of everything. I have now changed this one into slope-intercept form. This one is not in slope-intercept form either, so I'm going to rewrite it, and I'm going to change it as well. Again, it needs to start off with y, get rid of that x there at the beginning. Not like terms, put them in the correct order. To get rid of this 2, I need to divide each one of these terms by 2. Y is equal to, remember, there is a negative 1 sitting in front of this x. So this is negative 1/2 x. And 6 divided by 2 is positive 3. So what I've done is I've changed these equations right here into these two equations. And these are the two equations I'm going to use. Because these two equations and these two equations are exactly the same. So now it's like all the previous other examples. Y is equal to this and y is equal to this. That means these two things are equal to each other. 3x minus 4 is equal to negative 1/2 x plus 3. Remember, to get rid of a fraction in one of these, I need to multiply by a common denominator. And what's my only denominator? 2. I'm going to multiply everything by 2. 2 times 3x, 6x. 2 times negative 4, negative 8, is equal to 2 times negative 1 is negative 2, divided by 2, negative 1x. And 2 times 3 is 6. This is the variable that's in the wrong spot. The opposite of negative 1x, positive 1x. 6x plus 1x, 7x. Bring down the negative 8. This is eliminated. Bring down the 6. Need to get rid of this negative 8. Opposite, positive 8. 7x is equal to 14 because this is eliminated. Divide both sides by 7. X is equal to 2. I've got half of my answer because I've got the x coordinate. Now I need to find the y coordinate. And what I can do is I can plug this into any of these equations. I can plug it into the very first one right here at the very beginning. So I'm going to do that. I'm just simply going to plug it into that one right there. Make sure I plug it into the x. That's going to be 3 times 2 minus y is equal to 4. 3 times 2 is 6 minus y is equal to 4. I need to get rid of this positive 6 by subtracting 6 from both sides. Make sure I bring down negative y is equal to negative 2. And what am I doing to both sides right here? I'm dividing by that negative 1 that's in front. Y is equal to 2. So now I've got my y coordinate. So if these are not in slope-intercept form, change them into slope-intercept form. Use these to work it like we did in our previous examples, and then plug or substitute this variable, this value for that variable into any of these equations. Just simply plug it into the very first one.